Okay, today's lesson is going to be called tricky elimination problems.
Hey, Mr. Bean, I don't think that is how you spell tricky. Tricky.
Oops, I don't think that's how you spell tricky. Tricky elimination problems. So they're just problems that have some issues with them all of the time. And what I want to start out with are making sure, let's see, I have 1, 2, 3, 4, 5, 6, 7, 8 of them, just so you can kind of have a sense for where we are in the lesson. The first one, what I would like you to put down is 6y minus 5x plus 18 equals 0, and 9y equals 9x minus 18. And what I want you to do is check and see. I want you to answer the question, is -6, -8 a solution? Okay, so that's the question. Is -6, -8 a solution? Okay, so really what we have to do is plug it. Remember, solutions make both of these true. So we just need to plug these in over here and see if they make them true. Now remember, that's the x and that's the y. So if I go plug those things in there, this top equation right there is 6y. So I'm going to plug the y number where that y is, which is -8. So there's the 6y minus 5x, but x is -6. And then there's plus 18. And we want to see if it's 0. That's the question. Is it 0? Okay, well, this is -48. A negative times a negative is a positive, so that's positive 30. This is 18 still. Is that equal to 0? So -48 plus 30 is -18 plus 18 equals 0. So that's a yes. Check. Now it has to make them both true. So now I'm going to plug it into this one. That made the first one true. Check. Let's plug it in the next one. So the next one is 9 times y. The y number is right there at -8. Does that equal 9 times x? The x is right there at -6 minus 18. Well, this is -72. 9 times 6 is -54 minus that 18. -54 minus 18 is -72. Check. So the answer to this problem is yes. That is the solution to this problem. So if they're asking you for a solution, see, that's what we're always finding when we're finding these points. Those are the two numbers that make both of those original equations true. So if they're asking you if they're true, you just plug them in and see if they actually work.
Hey, Mr. Bean, why has it taken so long to put me in another video?
Okay, let's try another one like that. What about -14 equals -7x plus 8y, and then 3y equals -3x plus 6. And I would like us to ask, is 0, 2 a solution? Now, is 0, 2 a solution? Now, order matters here. 0 is the x and 2 is the y. You can't put them in any order you want. So 0, 2, the x has to be the 0. So let me just take this one right here. That is -14 equals -7x, so -7 times 0, plus 8 times y, so 8 times 2. So we have -14 equals, well, that's 0, plus 16. So this is a no. We don't have to try the other one because it has to make them both true. So if it makes one of them false, then the whole answer is false. Because I didn't think anybody noticed that you were gone. All right, what if it's a complicated one? What if it's got a bunch of fractions in it? So let's do letter C right here. Let's start out with 11 minus 2y minus 2x equals 0. And match that up with 5y equals 4x plus 3. And let's say the question is asking is, I don't need to put the word is 49/18 for the x and 25/9 for the y the solution? Okay, so look at that mess. We're going to plug that in for the x and that in for the y, and hopefully we have some kind of trick. Well, let's take a look here. Let's take this very first one right there. That's 11 minus 2 times y, which is 25/9. Minus 2 times x, which is 49/18. We want to see if that equals 0. Now, I sure would hope that there would be some kind of way to make these fractions go away, but remember there always are. I actually think I'll multiply it together at the beginning because that's not very hard. We have 11. This is just multiply the tops, so that's 50. 1 times 9 is 9, so that's really 50 over 9. And this is 2 times 49, so that's 98 over 18 equals 0. Now, we could get a common denominator and do all of that, but remember, we can make fractions multiply away if we just do it to all of them. It looks like 18 will make all of these fractions go away. If I multiply that times 18, this times 18, this times 18, and the 0 times 18, okay, this is the hardest thing I have to do here, 18 times 11, so that's 8, 1 times 1, 0, 8, 1, 8, that's 100, and so this piece right here is 198. Now, this 9 divides that 18 twice, so I'm left with 2 times 50. This 18 divides that 18 all the way away, so I'm just left with minus 98. Okay, well, let's see. 198 minus 100 is 98 minus 98. Sure enough, that one is check. That one works. So even if we have strange fractions, they're not that big of a deal. We're just going to deal with the strange fractions. Okay, now we got to get the other one to work. The other one is 5 times y. Y is 25/9. Equals 4 times x. X is 49/18. Plus 3. Okay, well, let's get a common, let's make a fraction, so multiply. 5 times 25, that's 125, and 1 times 9 is 9. Let's see here. What is 4 times 49? 196, and 1 times 18 is 18, plus 3. Okay, same thing. It looks like an 18 will get all these to go away. So I'm going to multiply by 18, 18, and 18. Okay, 9 cancels 18 down to 2, so I'm left with 2 times 125. So that piece is 250. Here, 18 cancels out 18, so that's 196. And 18 times 3 is how many? 54. So that piece became 54. Well, sure enough, 250 does equal 250. Check. The answer to this one is yes. that fraction set was the answer to those equations.
Really? Nobody noticed I was gone?
Okay, let's take a look at one more like that. For letter D, let's make 3x minus 4y equal negative 15. And match that up with 6x minus 8y equals negative 30. Now, can we tell that these are the same equation? Because if I take this one right here and just cut it all in half, that's 3x minus 8y equals negative 30. And this, oops, cut it in half. Let me cut it in half. It's 3x minus 4y equals negative 15. I'm taking this one and cutting it in half. And then this one is 3x minus 4y equals negative 15. That looks like infinite solutions. They're exactly the same equation. But here's what this problem is asking. It's asking, is negative 1, 3 an answer? Is 3, 6 an answer? And is negative 4, negative 2 an answer? Does infinite solutions does it mean everybody works? Well, let's plug it in there. Let's take this first one first, negative 1, 3. So I'm going to plug it in the first. Both equations are the same, so we're really only going to have to do it once. So that first equation is 3 times x, which is negative 1, minus 4 times y, which is 3, and we're checking to see, does it equal negative 15? Okay, well that's negative 3 minus 12 is negative 15. So this one is a yes. So that one is yes. Now I'm going to do the 3, 6. So the first equation, 3 times x, so that's a 3 this time, minus 4 times y, which is a 6. Does that one equal negative 15? Well, 3 times 3 is 9, 4 times 6 is 24, and 9 minus 24 is negative 15. So this one is also yes, so that one is a yes. So it looks like that's what infinite solutions means. It means everybody works. But that's not necessarily true. Remember what infinite solutions meant when we graphed it? It meant one equation was there and another equation was there. All of these dots are solutions, but these dots out here are not. So there's infinite answers, but that doesn't mean every dot in the universe is an answer. It's only the answers that are on those lines. So let's try the negative 4, negative 2 if I stick that in. So the first equation is 3 times x, but now this one is a negative 4. Minus 4 times y. Now this one is a negative 2, and we're checking to see, does it equal negative 15? Well, this is negative 12, and negative 4 times negative 2 is plus 8. That's negative 4 equals negative 15. No, this one is not an answer set to those. Negative 4, negative 2 does not make that true, where the other ones did. So this was yes, this was yes, this was no. So when we're plugging these values in there, we're checking to see if it makes it true. Some points do, and some points don't. Okay, so that's checking things to see if they work. You can always check your answer to see if you have it right on these kind of problems, because you just plug it in and see if it makes it true.
Okay, they noticed. That's why I brought you back.
Okay, let's try. So those weren't necessarily tricky. I just wanted to get those in front of you. But let's try some tricky elimination problems. What if we have 4y equals negative 6x minus 4, and that is matched up with negative 7x equals negative 12 plus 3y. Now I only call this tricky because they're not in a nice order. we need these to be all in the same order so that we can match them all up. I really need this 6x to go over there. Well, just pick it up and put it over there. If it's a minus 6x on this side of the equal sign, it's a plus 6x on this side. So we could rewrite that as a positive 6x over on this side that's now with that 4y that was already over there. And then what was left over onto the right side was this minus 4. So we can rearrange these things any way we want. And then likewise, I would pick this 3y up and put it over there. See, we would be subtracting 3y from both sides. So if it's positive on this side, it will be negative on this side. So I already have a negative 7x. We're moving this 3y over there, so it's minus 3y. And then it all equals negative 12. Okay, so now I have them in order. Now I'm going to go and try to make one of the equations eliminate itself. So I'm going to rewrite that over here. I have 6x plus 4y equals negative 4. And we have negative 7x minus 3y equals negative 12. I like to have room to go this direction just so we can see what's happening. So my eyeball is coming to these two right here. I would like to make those two a 12. So to make the 4 a 12, I need to say times 3. And to make the 3 a 12, I need to say times 4. So I'm going to triple the top one and quadruple the bottom one. So everybody here gets times 3, so that's 18x. 4 times 3 is 12y. And negative 4 times 3 is negative 12. And everybody on the bottom gets multiplied by 4. So negative 7 times 4 is negative 28x. Negative 3 times 4 is minus 12y. And negative 12 times 4 is negative 48. And let's just add them up. See, now the 12s. Minus 12 plus 12 is going to go to 0. I'm going to take 18 and plus negative 28. So that's going to be negative 10x equals... And here I'm going to add these up. Negative 12 and negative 48 is negative 60. Divide off the negative 10. And we have x equals 6. I'm going to go ahead and take that 6 and put it any place there is an open x, which on my paper is right there. So that's going to be negative 7 times x, which is now 6. Minus 3y equals negative 12. This is negative 42 minus 3y equals negative 12. Add 42 to both sides. So now let's see here. We have what? Negative 3y equals 30. Divide off the negative 3, and we have y equals negative 10. So our final answer is x is 6, y is negative 10. Now, if you want to check that and make sure you have it right, if you're on a test or something, just go plug it back in, one of these first equations, and it should make it true. If I wanted to check it, I would put the 6 where there's an x. So there I have a 6 times an x, which is another 6, plus 4 times the y, which is negative 10, and test and see if it equals negative 4. If it does, you probably have it right. So 6 times 6 is 36. 4 times 10 is negative 40. So 36 minus 40 is negative 4 equals negative 4. I'm pretty sure I have it correct. Now, I should go put it in the other one, but if one of them is correct, it's pretty likely the second one is correct. So I don't want to spend the time on that.
Yay! Yay! I'm back! I'm back! I'm back!
Okay, so the tricky part is on these, it's not really that tricky. Just rearrange it and make the problem nice. So let's take this one for our letter F. Let's say we have 0 equals negative y minus 5/4 x. And then the other one is negative y minus 6/5 x minus 2/5 equals 0. That doesn't look nice. It looks like a mess because of those fractions. But one of the things I try to emphasize is you don't have to deal with fractions. Like on this top one, a 4 will get rid of them all. So I'm going to multiply everybody by 4. If I multiply everybody by 4, 0 times 4 is still 0. This is going to be a negative 4 with a y, so just negative 4y. And those 4's are going to cancel out, leaves negative 5x. See, we cleaned up the fraction. The bottom one, I'm going to multiply everybody times 5. Okay, that will clean up the fraction. Negative 5y, okay, so I've got a negative 5 with a y. That 5 and that 5 cancel out, so it just leaves negative 6x, so minus 6x. That 5 and that 5 cancel out, so it just leaves minus 2. And 5 times 0 is still 0. Okay, got rid of the fractions. Now I would probably like to maneuver these so that they are on the same side. Well, the x and the y is already pretty good, so I think I'll just leave that. I like to have it the other way around. Negative 5x minus 4y equals 0. See, same thing. It's still a negative 5 and a negative 4. Probably I would pick up this 2 and put it over there. If I pick up this 2 and put it over there, it's a positive 2. And then the minus 6x and the minus 5y are here. So there we go, minus 6x minus 5y. Now we have it nice and clean, no fractions, all in the right order. I just need my eyeball to get one of them to be the same. I personally would probably go for a 20 right here. So I'm going to take this one times 5. So here I'm going to go times 5. Negative 5 times 5, way over here gives me a negative 25x. I've got negative 25x out of the first piece. 5 times negative 4 will give me a negative 20y. And 5 times 0 is 0. This one I think I'll multiply by negative 4. Because that'll make this a positive 20 to go with that one. So negative 4 times negative 6 is 24x. Negative 4 times negative 5 is positive 20y. And negative 4 times 2 is negative 8. Okay, let's add this up. See, 20 and minus 20 go away. They got eliminated. Negative 25 plus 24 is negative 1x. And 0 plus negative 8 is negative 8. Let me just divide off this negative 1, and we have x equals 8. Take that and plug it in wherever we want. I'm just going to plug it right there because it's easy on my paper. So that's negative 6 times x, which is now 8, minus 5y equals 2. So that's negative 48 minus 5y equals 2. Do what we do. We'll add 48. So we have negative 5y equals 50. Divide off the negative 5. And we have y equals negative 10. So our final answer, the x was 8, the y was negative 10.
Mr. Bean, can we go visit the mean guy, please?
Okay. That's 6. We have 2 to go. Let's try G. Here's the problem with G. G has an interesting problem. Okay, here's the original problem. 6y minus 9x equals 5, and negative 5 plus 9y minus 5x equals 0. Okay, well, first of all, the bottom one is all mixed up. Well, it's not actually that bad, is it? How about I take this minus 5 and put it over there, and that will make things better. So I think I'll just rearrange the top one and put the x in the front. I mean, it doesn't really matter. Well, actually I won't. I'll just leave the 6y minus 9x equals 5. Then the bottom one is going to be 9y minus 5x, and we put this 5 over here, so it also equals 5. Okay, well, I don't know, it's 6 of one, half a dozen of the other. I need to make these go to 45, or these go to 54, or actually these could go to 18. How about I make these go to 18? That might be nice. I take the top one times 3 and the bottom one times 2. So let's just go times 3 for that one, maybe times -2 for that one, so we can have opposite signs. Okay, so 6 times 3 makes this one 18y. -9 times 3 makes this minus 27x. And 5 times 3 makes it 15. This one, if I take times -2, 9 times -2 is -18y. -5 times -2 is plus 10x. And 5 times -2 is -10. Okay, when I add those up, that's gone. -27 plus 10 is -17x. And right here, 15 minus 10 is 5. Divide off the -17, and we have x equals -5 over 17. Okay, that does not look very fun to go plug up in here. I mean, we could. We could take this x, plug it up in there, and just deal with the fractions. Or here's my super trick. When you get an answer that's a fraction, you could plug it in and multiply through by 17 and it would all go away and you wouldn't have fractions again. Or here's another little trick. You can use this or not. Go back to the original and make this one the same. Now let's go to 45 on this one. If I do that, I'm going to take this top equation and multiply it times 5. So I'm going to take this one times 5. 6 times 5 is 30y. -9 times 5 is minus 45x. And 5 times 5 is 25. Then I'm going to take this one right here times 9. Remember, now I'm going for the purples. I'm trying to get these to be 45. In fact, I think I'll make it times -9. So I'm taking the bottom one times -9. 9 times -9 is -81x. Oops, y. Sorry, y. -5 times -9 is plus 45x. That's good. See, the 45s are going to drop out. And 5 times -9 equals -45. Now, when I add these up, -81 plus 30 is -51y. Those go away like they're supposed to. And over here, -45 plus 25 is -25. Divide off the -51. And we have y equals 25 over 51. And there's our answer, -5/17 and 25/51. So we got this really complicated answer, and I didn't really do any fractions anywhere. First, I took this problem and made the y's go away. Then I just redid the same problem and made the x's go away, and I got these complicated answers without ever having to do a fraction kind of problem. Okay, I thought I probably ought to do another one of those just to make sure, so that we can see at least 2 of them before the...
Okay, Mr. Dean, don't get too crazy. Remember, you can't kill him. Everybody will get mad.
Homework. So if something complicated happens, so let's try this on H. 6 equals 3x plus 10y. Match that up with 4x plus 7 equals 5y. Okay, I don't really mind too much, except I think I'll take this 4 and put it over there, and it'll be a minus. So if I do that, what I have is 5y minus that 4x, and then it equals 7. I'll just put equals 7 over here. On this one, it's all kind of already nice. So I'll put the 10y here because they got to stack up. Then I have a plus 3x, and that equals 6. Well, my eye looks right here, right off the bat. It looks like we can go for tens. All I have to do is the top equation. So I'm going to take this top equation times -2. Because that'll make this 5y a -10y. So 5 times -2 is -10y. 4 times -2 is positive 8x. And 7 times -2 is -14. I'm almost out of paper there. This one, do nothing. 10y plus 3x equals 6. Okay, the 10s went away. Excellent. 8 and 3 make 11x. -14 and 6 make -8. Divide off the 11. And there's my first answer. X equals -8 over 11. I could take that, go plug it in right there, and just deal with it. But I don't want to because of that ugly answer. I'm going to go back to the original equation and try to make these 12. So if I multiply this one times 3, so now I'm just going to start over and multiply times 3 because that'll make the x a 12. And I'm going to multiply this one times 4 because that'll make this one a 12. So doing that, 3 times 5 is 15y. 3 times -4 minus 12x. And 3 times, oops, sorry if I'm off the page. I did 3 times 5, got 15. I'm doing 3 times -4 is minus 12. And I'm going to do 3 times 7. Here I'm going to multiply by 4. 4 times 10, 40. 4 times 3, 12x. And 4 times 6 makes it equal to 24. And now let's add these up. See, those go away. 15 and 40 make 55y. 21 and 24 make 45. Divide off the 55, and we have y equals 45 over 55. We can divide both of those by 5, so that equals 9 11s. And that is our answer. The x is -8 11s, and the y is 9 11s. Now, I'll probably on the main test, or I'll probably have one problem that does this. So this is not a huge deal. So don't let the fractions get you all frustrated. If you need some help on the homework, I will help you on that one. But most of them are like these, where you just have to rearrange the problem and then it just comes out to a nice answer.
Come on, let's go visit.